Ever wondered what holds our world together? Skyscrapers that kiss the clouds, bridges that span vast rivers, and even the cozy home you live in. The secret ingredient? Cement. It's the unsung hero of construction, and today we're going on an epic journey to uncover how this magical gray powder is made, from a rugged quarry all the way to a bustling construction site. So, what exactly is cement? Think of it as the glue for concrete. When you mix cement with water, sand, and gravel, a chemical reaction kicks off, binding everything into the rock-solid material we call concrete. But where does this incredible journey begin? It all starts deep within the earth, in a quarry. Our first stop is the quarry, where the primary raw materials are extracted. The main player here is limestone, a sedimentary rock rich in calcium carbonate. Huge excavators and loaders work tirelessly, digging up tons of limestone. But it's not just limestone. We also need other materials like clay, shale, or iron ore to get the perfect chemical mix. These provide the necessary silica, alumina, and iron oxide. Think of it as baking a giant, industrial-scale cake. You need the right ingredients in the right proportions. Once these massive rocks are blasted and gathered, they're loaded onto enormous dump trucks, some as big as a small house, and begin their trip to the processing plant. Now we're at the plant, where the real transformation begins. The first step is crushing. The huge chunks of rock from the quarry are way too big to work with, so they're fed into a series of powerful crushers. Imagine giant mechanical jaws chomping down on these rocks, breaking them into smaller and smaller pieces. A primary crusher handles the largest boulders, followed by a secondary crusher that reduces them to the size of gravel. It's a loud, dusty, and incredibly powerful process, all designed to prepare the materials for the next crucial stage. After crushing, the raw materials are carefully analyzed and blended. This is where precision is key. Samples are taken to a lab to ensure the chemical composition is just right. Based on the results, different raw materials are mixed together in exact proportions. This mixture, now called raw meal, is then ground into a very fine powder in a massive rotating mill. Inside this mill, large steel balls tumble around, pulverizing the material until it's as fine as flour. This fine powder is essential for the chemical reactions that will happen next. And now, we arrive at the heart of the cement plant, the kiln. This is where the magic truly happens. The raw meal is fed into a colossal, rotating cylindrical kiln. These kilns are massive, often hundreds of feet long, and are slightly inclined. As the kiln slowly rotates, the raw meal tumbles its way down towards the heat. And when I say heat, I mean intense heat. The temperature inside the kiln reaches a staggering 2,700 degrees Fahrenheit, or about 1,450 degrees Celsius. That's hotter than volcanic lava. Inside this fiery inferno, a process called calcination occurs. The intense heat drives off carbon dioxide from the limestone and causes the materials to fuse together, but not completely melt. They form new compounds, creating small, marble-sized, dark gray nodules. This new material is called clinker. The clinker then tumbles out of the hot end of the kiln and into a cooler, where it's rapidly chilled with blasts of air. This rapid cooling is vital for creating the desired chemical structure in the clinker, which gives cement its strength. We're almost there. The cooled clinker is the intermediate product, but it's not cement just yet. To turn it into the final product we all recognize, it needs one last grinding session. The clinker is transported to another large rotating mill, similar to the one used for the raw meal. Here, a small amount of gypsum is added. Why gypsum? It's the regulator. Gypsum controls how quickly the cement sets when mixed with water. Without it, the concrete would harden almost instantly, making it impossible to work with. Inside the final grinding mill, the clinker and gypsum are ground together into an incredibly fine gray powder. This is it. This is Portland cement, the most common type used around the world. The fineness of the powder is critical. The smaller the particles, the larger the surface area, which leads to a faster and stronger reaction when water is added. Once the cement is produced, quality control is paramount. Samples are constantly taken and tested in the laboratory to ensure they meet strict industry standards for strength, setting time, and chemical composition. Consistency is everything. Every bag of cement has to perform reliably. After passing all the quality checks, the finished cement is stored in large silos, ready for distribution. From the silos, the cement is packaged for its final journey. It is either loaded into large bulk tankers to be delivered directly to major construction projects or precast concrete plants, or it's packed into the familiar paper bags you see at your local hardware store. These bags are filled, sealed, and stacked on pallets by automated machines, ready to be shipped out by truck, train, or even ship. And that brings us to the final destination, the construction site. Here, builders mix the cement with water, sand, and aggregates to create concrete. This versatile mixture is then poured into forms to create foundations, walls, beams, sidewalks, and so much more. As the concrete cures, the cement and water undergo hydration, forming a dense interlocking crystal structure that binds all the components together into an artificial rock. It's this incredible chemical process that gives our buildings and infrastructure their strength and durability. So, the next time you walk on a sidewalk, drive over a bridge, or look up at a towering skyscraper, take a moment to appreciate the incredible journey of cement. From the raw power of a quarry blast to the intense heat of the kiln and the fine precision of the grinding process, it's a testament to human ingenuity and engineering. It's a journey that turns mountains into the very foundations of our modern world. Thanks for joining us on this deep dive into cement production. If you found this fascinating, be sure to hit that like button and subscribe for more behind-the-scenes looks at how our world is built. Let us know in the comments what other industrial processes you'd like to see. Until next time, keep building.